Welcome back to Web Design and Development 1, CMP122. I still remain Associate Professor Uche Mbanaso, and I'll be taking you with this course. So this is Lecture 1. In this Lecture 1, we'll be looking at Introduction to Internet to be able to lay foundation of understanding of the Internet infrastructure. We look at the computer network, the TCP/IP protocol stack, the domain name system. The modern world is a staggering complex place, comprising level upon level of dynamic interacting systems. So we can rightly say that almost everything today is interconnected. People are interconnected, machines are interconnected, and these interconnections are sometimes for sharing information, creating content, processing, storing information, use information for collaboration, partnership. So the internet has become a complex environment in which all manner of networks, applications, interactions do take place. So when we talk about internet infrastructure, we can view it from different perspectives. So one perspective is a global computing network providing a variety of information and communication facilities, consisting of interconnected networks using standardized communication protocols. So it is based on the internet, which is a global system of interconnected computer networks. The use of the Internet Protocol Suite, TCP/IP, to link devices worldwide. The TCP/IP stands for Transmission Control Protocol / Internet Protocol. It is a network of networks that consists private, public, academic, business, government networks of all of local to global scope, linked by a broad array of electronic, wireless, and optical network technologies. The internet carries a vast range of information resources and services. The internet is a global network of billions of computers and other computing devices. It provides the possibility to access almost any information and communication which anyone else in the world, and more can be done while on the internet. The internet, sometimes referred to simply the net, can also be described as a worldwide system of networks, a network of networks in which computers at any one network can, if access permission is given, get information from any other computer or at other computers. It was first conceived by the Advanced Research Project Agency of the United States government in 1969 and was first known as ARPANET. So if we take example, we can see in Nigeria we have MTN network, you have Glo network, you have One network, you have Galaxy Backbone network, we have Airtel network. So but when these networks are interconnected together, they form what we call the internet infrastructure. So the internet infrastructure also can be looked from global perspective. So we have the superhighway. So we can have the same set of arrangement from Ghana. We can see Ghana also consists of a network going to superhighway, Nigeria, USA, and India. So this is how the internet is formed. And it's very, very important to understand the concept behind this network topology that makes the internet. In physical infrastructure, the internet leverages a portion of the total resources of the currently existing public telecommunication network. So what are we trying to say is that physical infrastructure of the internet still leverages traditional telecommunication networks. Technically, what differentiates the internet is the use of set of protocol referred to as transmission control protocol and internet protocol. Two recent adaptations of internet technology, the intranet and extranet, both leverage the TCP/IP protocol. The internet has two main components, network protocols and hardware. The protocols, the TCP/IP stack, presents a set of rules that computing devices must follow in order to complete digital tasks. Communication between computers is impossible without this common collection of rules. The protocols are also responsible for transferring a fragmented of messages into electronic signals that can be transmitted over the internet and then back again into legible alphanumeric text. So when we look at computer networks, just for a basic understanding, a computer network can be two computers that are linked back to back. It can be two computers linked back to back. Another way of looking at computer network is also a network that is connected through intermediary, like a router and a switch. So they can also form a network. However, there is possibility of having public network. This is where the internet infrastructure comes in, whereby the host B and host A are not in the same domain. So there are systems in different domains that are only linked up by the internet. And a typical example of this is when you want to access a website. You go to your host computer, which is host A, and then you try to invoke your browser. Your browser comes, you type in www.com. Once you hit that button, the rest takes through the internet, reaching the server and fetch the information back to the user. And so this foundation is important. Depending on the type of application you want to develop, you'll be able to know the basic attributes of the network that will actually serve your purpose. So when we talk about transmission control protocol and internet protocol stack, this tells you how transactions between two computers do take place. So the first layer of a TCP/IP protocol stack is what we call the application layer. This application layer produces user data. So after the application layer, we have the transport layer. And that transport layer encapsulates the TCP header and then the user data from the application layer. The next is the internet, and the internet also encapsulates the IP header, the TCP header, and user data. Of course, we are all aware of the network interface. So you have the internet header, the IP header, the TCP header, the user data, and then the internet controller. What does this translate? We can see that from the application layer going down to the network interface, there is a sort of encapsulation of the previous layer to the next layer. This encapsulation helps two computers communicating together to remain more focused in the communication between them, understanding every aspect of that communication and how it do take place. So the transmission control protocol is a communication standard that enables application programs and computing devices to exchange messages over a network. So without this TCP, conversation in the internet will be impossible. It is designed to send packets across the internet and ensure the successful delivery of data and message over networks. TCP/IP is one of the basic standards that define the rules of the internet, and it's included within the standard defined by Internet Engineering Task Force. It is one of the most commonly used protocols within digital communications and ensure end-to-end data delivery. The TCP organizes data so that it can be transmitted between server and client. It guarantees the integrity of the data being communicated over a network. Before it transmits data, TCP enables a connection between a source and its destination. So looking at before it starts, you will see that there's a connection between host A and host B. The host A being the initiator and host B being the destination, which ensures remain live until communication begins. It then breaks a large amount of data into small packets while ensuring data integrity in place throughout the process. As a result of high-level protocols that need to transmit data, all use TCP protocol. Examples include peer-to-peer sharing methods like file transfer protocol, secure shell, and telnet. It also used to send and receive email through internet message access protocol, post office protocol, and simply mail transfer protocol, and for web access through the hypertext transfer protocol. An alternative to TCP in network is the user datagram protocol, UDP, which is used to establish how latency connections between applications and decrease transmission time. TCP can be an expensive network tool as it includes absent and corrupted packets and protects data delivery, which controls like acknowledgements, connection, startup, and flow control. However, UDP does not provide error connection or packet sequencing, nor does it signal destination before it delivers data, which makes it less reliable but less expensive. As such, it is a good option for time-sensitive situations such as domain name systems, lookup, voice over internet protocol, and streaming media. The Internet Protocol is the method of sending data from one device to another across the Internet. Every device has an IP address that uniquely identifies and enables it to communicate with an exchange of data other devices connected to the Internet. Today, it is considered the standard for fast and secure communication directly between mobile devices. IP is responsible for defining how communications and devices exchange packets of data with each other. It is the principal communication protocols responsible for the formats and rules for exchanging data and messages between computers on a single network or several internet-connected networks. It does this through the Internet Protocol Suite, a group of communications protocols that are split into 4 abstraction layers. The Domain Name System. The Domain Name System, DNS, refers to a naming database in which the Internet domain names are created and mapped into Internet Protocol addresses. The Domain Name System maps the friendly name Internet user used to locate a website by retrieving the underlying IP addresses of the computer hosting the website. Web browsing and most other internet activities depend on the DNS to quickly provide information necessary to connect users to remote hosts. The DNS mapping is distributed throughout the internet in an hierarchical form of authority. So, if you want to look for www.somesite.com, so once you type that into your browser, it will go to the distributed DNS server to begin to look for the IP address that can match that particular domain. Once that IP address and the domain are found, then it returns back to the browser. But you, the user, won't be able to notice what is happening. It is done behind the scene. So the web browser redirects the page to the web server, from where the web server will now return a response to that request. If that particular resources being looked for is available, it returns it to your web browser and it will display. So browser basically only we type a friendly name, sometimes some site.com. But with that, a computer cannot communicate to a computer. So for it to communicate, it must go and look for the IP address of that computer. So here we're looking at the IP address of the web server and has to be retrieved from the DNS server for it to be able to function. How DNS works. DNS servers convert uniform resource locators, the URLs, and domain names into IP addresses that computers can understand and use. The DNS servers translate what a user types into a browser into something the machine can use to find a web page on a website. The process of translation and lookup is called the DNS resolution. The basic process for a DNS resolution are as follows. The user enters a web address, www.somewebsites.com, or domain name into a browser. The browser sends a message called a recursive DNS query to the network to find out where the IP or a network address that the domain corresponds to. So it will go through different domain name registers and begin to look for the mapping of an IP address to that domain name. The query goes to recursive DNS server, which means looking at different server, which is also called the recursive resolver and is usually managed by the internet service provider. If the recursive resolver has the address, it will return the address to the user and the web page will load. If the recursive DNS server does not have an answer, it will query a series of other servers in the following order: DNS root name servers, top-level domain name servers, and authoritative name servers. The three server types work together and continue redirecting until they retrieve the DNS record that contains the requested IP address. It sends this information to the recursive DNS server, and the whole page the user is looking for loads. DNS root name serves as TLED, which is the top level domain servers. Primarily redirect queries and rarely provide the resolution themselves. The recursive server stores, caches the air record of a domain name, which contains the IP address. Next time it receives a request for the domain name, it can respond directly to the user instead of a computer servers. If the query reaches the authoritative server, it cannot find information, it returns an error. Thank you. We've come to the end of this lecture 1, and I do hope you have enjoyed the lecture. Thank you.